All right, everyone. Welcome to our 6th section on iOS. Today we'll be covering MapKit, some notifications you can do in iOS, and then some media, like playing movies. So here's today's agenda. I'll look at how to integrate Google Maps with any of your apps, because as you move on to Students' Choice apps, that's a really popular topic amongst people, mapping things and drawing things on maps. And then we'll move on to some other multimedia stuff and other location-based things. But first, I just wanted to talk a little bit about code style, since we're about halfway through the course now, and this is something that some people have had questions on. So code style is something that is very, very near and dear to my heart. And it's also something that, if you do correctly, you can really get a lot of points that you'd otherwise be throwing away on these projects. So I just wanted to walk through a couple things that we've seen on projects, things to do and things not to do. So first, here's a good example of a few things that you should not do. So you see here that I have two functions, and these are just in PHP, but all of these same rules are going to apply to Objective-C. You'll see I have a getter and a setter here. So the getter, you'll see I'm using camel case. I have a lowercase g, capital I to separate the two words. But then the setter associated with the same property is using an underscore. And so this is really inconsistent. So you want to pick either camel case or underscore in your style guide and stick to it. You also see here this first method here has the public keyword, which is optional. If I don't include that public, the function is going to be public. And the second one omits it. So even though these two things are the same thing, it's really inconsistent to omit these. And then finally, you'll see that the brace placement is different on two of these methods, which is pretty annoying. The first one has brace on its own line, and the second one has its brace on the same line. In particular, there's no space here between the closing parentheses and the opening brace, which personally irks me. But if you're going to do that, make sure that you're consistent throughout. So this is just an example of a few things that we don't really want to see on your problem set. So definitely try to remove those before you pass them in. So something else, you'll see here, these are a couple lines that are loading maybe the header and the footer view. So these comments here say that this loads the view called header. If you actually read this line of code out loud, this loads view header, it's self-explanatory. There's really no need to have a comment that's that verbose over each of these lines. So try to group your code into similar blocks, like a small block of code of 5 or 6 lines that accomplishes something, then comment what that kind of group of code does. There's no need to comment individually every single line, particularly when it's as self-explanatory as that. So next, when you're naming your variables, you can do one of two things. First, please don't have variable names that are this long. So in Objective-C, this is something you can't really fix, because a lot of the library methods are this long. But in PHP, that's not really a convention. Similarly, something else that kind of personal pet peeve is when people remove vowels from variable names as a means of shortening them. So instead of saying list of items, they'll say list of items. And for some reason, this is a pretty common convention. But this is really an unreadable variable name. And just glancing at that is going to make it really hard to tell what that variable is doing. So again, this is something that we do not want to see in your code. Finally, another word on commenting. Please be consistent with doing the way that you're demarcating your comments. So if you have a single line comment, don't use a double slash in one place and then the /* at another place. Similarly, don't put it above the line of code in one place and then next to the line of code in another place. And again, these are two lines of code that really don't warrant comments in the first place. But the point is, don't mix your type of comments inside of your code. So if that's all clear, let's move on to some more iOS topics. So first, we're going to be covering MapKit, which is an implementation of Google Maps. And it's actually using Google Map data for iOS. So everything that we're going to be using today is contained in a single header file that you care about, and that's mapkit/mapkit.h. That slash, just as you might expect, indicates that this is located in some subdirectory of a system folder. And we're also going to need to do something new, and that's working with a framework file. This is effectively the same as a static library, or some already compiled code that needs to be linked in. So you're not actually importing all of the source. This is just a static library that the linker is going to be concerned with. So a couple terms that we'll need to be familiar with when we're starting to work with maps. So again, these are really long names. But first, you can have a coordinate on a map that has a latitude and a longitude. Just a standard floating point decimal. You can go as specific as you want. Then you can also define a span. So basically, some region that starts at some point and goes to the left, or goes laterally and vertically some distance. So a latitude delta and a longitude delta is how many degrees of latitude and longitude you want this area to cover. And so with a point and a span, you can form a region, which can be in basically a rectangle that defines an area on the map. So using those two terms, let's just take a look at a very basic example. So in order to get the map view onto my app, it's really simple. Even though that this is contained in some separate library, all I've done here to get this MK map view, so I've come down over here and I started typing map, and there's my map view. I can just drag and drop. So if we jump into my header file, you'll see here that this map view, unlike things like NSDictionary and NSArray, are not included for me by default. This is kind of some separate framework that isn't included into my build by default. So you see here, in order to use this MKMapView class, I have up here a forward class declaration. We've seen this before in a couple other cases where when we've had our own view controllers or we've defined our own models, and we wanted to use them as properties in other header files, if I didn't tell the compiler that this class existed, I'd otherwise get yelled at, because it's not going to know what this MKMapView is until I say that it exists. So instead of saying @class, I could have also imported a header file. But there's no real reason to do that, because all I need to tell the compiler is that this class exists. At this point in the story, the compiler does not need to know what this does or what properties it has. It just needs to know that I'm allowed to create an object of this type. So that is called the forward class declaration. So if I jump into here, into my implementation, we'll see now that I'm including that header file, mapkit/mapkit.h. Property is synthesized as normal. It's just a standard IB outlet that I connected in Interface Builder. And so now here are these three steps. So first, I'm going to create a starting point for my map. So this just happens to be Mather House, the latitude and longitude. So you can see here that I've defined this location coordinate. So unlike a lot of the objects, so this is not an object, unlike a lot of the other things we've been using, like strings and arrays. But this is just a standard C struct. So you see there's no star in my variable name or next to the type, because this is not a pointer. So because it's just a struct, I can use the dot notation, which in this case does not refer to properties. This is just standard C dot notation for indexing into a struct. And I can just set a latitude and longitude. So from that, I just want to say that I want my area to cover 0.002 in both directions. And finally, from my span and my center, I can create this region. Now with this region, I can define this to be the center of my map. So without this, my map would just show the entire world, the kind of the default state. But by sending this region that I've defined through a center and some area, I can tell the map what I want to be displayed initially. So one other thing we need to do in our project, remember, is import that .framework file. So this is something we haven't done yet. So if I come over here to my project properties, and I click this, you'll see I have summary, info, build settings. And I want to come over here to build phases. Click here, link binary with libraries. And you'll see I've already included mapkit.framework here. But to add that, I'm going to click on the little plus. I'm going to see a list of all these framework files that you're free to use, including like Twitter or some other integration. If I just start typing in map, you'll see that mapkit.framework comes up, and I can just add it with add. So if you forget to do that, sometimes your map won't display, or app will just otherwise crash. So that's an easy step to forget. But now if I run this, you'll see that I'm about to get a lot of behavior completely for free just with this single map component. So here we go. Here's my simulator. And now I'm zoomed in on Mather House. I can pan around to see all of Harvard if I want. I can pinch zoom in and out. And all of this is totally handled automatically for me. I didn't need to do anything. So if, for example, I wanted to start more zoomed out, I can just decrease these deltas by, so just right here. So I've just taken those two numbers and just made them slightly bigger. So I'm increasing the area that I want to be displayed on the map. So now if I rerun it, you'll see here that I'm significantly more zoomed out than I was before. So pretty straightforward on starting to use these points and regions. So another common thing that you've seen on Google Maps is those little push pins. So when you do something like search for a location or try to get directions, you'll often see those nice push pin things that demarcate locations. And again, this is nice behavior that's given to us for free. In this case, by the MK, so MapKit this time, no longer NS for next step. We're dealing with MapKit. So this MK point annotation class is effectively going to define a model. So again, we're back in this MVC approach, except these things aren't really going to have a C. We're mostly concerned with M and V. So this point annotation is a model, which means that it defines a coordinate for this to be located at. And it also has some text capabilities. So when I tap on it, I can see a title and a subtitle. So once I've formed this, I can actually add this model to my map view. which will display the corresponding view. So starting right where we were before, where we centered the map on Matherhouse, I now want to create a little pin on a location. So very, very straightforward. I'm just going to create a new instance of this point annotation. I'm going to define a starting coordinate, which I'm just using in this case, reusing the center of my map here. And its title and subtitle are just strings. And so finally, I can add the annotation to my map. So in this case, I've only created a model, and I'm basically using the default view for each of these pins. So once I run this, I'll now see an annotation. So if I tap on this, I get a nice little popover. It's transparency, and everything works really nicely. So any questions so far? OK. So that's all well and good, but maybe we want to customize these a little bit more. So we can actually customize both the model and the view. So first, let's take a look at how to customize the model. So to do that, I can basically define my own class for one of these annotations. And this class can have any properties that I want. Maybe I want to have some additional data stored or other things that can be passed to it via methods. So I need to implement, as you may have guessed, a protocol. In this case, just called MK Annotation. No delegate this time, since I'm not really providing a delegate here. I'm just defining some basic behavior that needs to exist inside of any annotation. So by saying I'm going to implement this protocol called MK Annotation, I'm telling iOS that I'm going to have properties called coordinate, title, and subtitle, which remember were just basically the three things that an MK point annotation had. So we're basically only extending this default behavior. So once I've created my model, I can also create some custom views. And we'll see here that this is the exact same paradigm as we saw with table views. So basically, the iOS is going to ask me separately in a method what I want each of my annotations to look like. So I probably want to, inside of my controller, have some list of models with corresponding properties and basically index into that array of models in order to display the appropriate view. So before, we had this UI TableView cell controller that had both a data source and a delegate. Now, instead of table views, we have this MK MapViewDelegate. And this is what's going to have iOS be asking me, as the controller, what I want all of my annotations to look like. And again, this was easy to forget with table views, but don't forget to connect the delegate of the map to your controller. So what I mean by that is if I jump back into my nib file and click on my map view, so if I come up here to the Connections tab, so all the way to the right, I want to take this delegate and actually connect it over to Files Owner. And that will set the delegate of the map view to be the current class. Because without that, the delegate is nil. And when iOS wants to ask something what each of these annotations are going to look like, it's just going to be passing messages to nil. So even though you've defined these methods, they're not actually going to get called by the system because you haven't told it what object has implemented them. So you simply do that by connecting the delegate to Files Owner. So before, we had this method TableView cell for row at index path. We now have a method that does exactly the same thing, this time called MapView, no longer TableView, and no longer dealing with cells, but we have annotations. And similarly, we're going to apply these same design principles with caching. So just as the user very rarely will have the entire table in memory, so we don't want to load the entire data set immediately, often we may have views that are off the map right now. So there's no reason to keep those guys around in memory either. So we have this analog method, DQ reusable annotation view. So rather than reusing cells, we're reusing each of these pins. So same exact principle that we saw before. So whereby cells, we basically just dealt with text and a little bit of accessory views. The pin annotation view has a little bit more flexibility in what properties you can change. You can change the pin. You can make it animated. You can, again, add some more detail buttons. And so finally, these are the analogs of the TableViewDelegate methods. So we have a method that's fired whenever I tap that accessory view, that blue button. I can have a method that fires whenever the user scrolls the map. So if I want to determine what the new center of the map is. And similarly, selecting and deselecting each of these views. So let's walk through a custom annotation that has both a model and a view that I've made myself. So first, let's take a look at the model. So here, I've created a new class simply by saying, as we said before, new file. And this time, I've just said Objective-C class. It extends an NS object because this isn't its own view controller. This is just a model. And so that gave me something that looked like this. So the first thing I need to do is say that I'm going to implement this protocol, this MK annotation protocol. Now, I can't just say this immediately because the compiler is not going to know what this is or where it's located. So in order to tell the compiler what this thing is, I actually need to import mapkit/mapkit.h. Because again, this is going to handle importing everything that I need. And this is where this protocol is defined. So without this import, the compiler is not going to know what this is. So as we said, we need to provide these three properties, and they need to be named as such. So I've done that simply by creating properties. Protocol also says that this one has to be called assign, and these two are both copies. If you try to do something other than this, the compiler will just give you a warning because it says the protocol is expecting this to have a different type. And so now I've defined a special method that is particular to my annotation, but not this generic annotation. And I basically found that a lot of the times, I've been setting these these three properties on 3 lines. So maybe to make that a little nicer, I'm going to create my own initialization method that rather than having 3 separate lines, can just pass in as much data as I want. So for example, rather than having to say annotation.coordinate equals, maybe I'll just say in my constructor, I'm going to pass in the coordinate to save myself some lines of code. So again, nothing special here. We're just synthesizing all the properties. And then here, this is where we're just setting the coordinate that was passed in. So our model's pretty simple. So let's move on to what we're doing with the view. So up to here, there's nothing special. So now I'm going to create 2 new annotations. So I'm using here this custom annotation class, which is extending the functionality of that default pin. So to do that, I've been sure to include both header files, the annotation I'm using, along with the default annotation, so I can get things like MK coordinate span, which are not defined automatically. And now I'm using this new constructor. So I'm saying init with coordinate, and I'm passing it my starting coordinate. And then I'm just setting the title and subtitle. Nothing special there. And now I'm just going to both add them both to the map. So if I run this, actually, before I run this, let's take a look at all these delegate methods. So first, this is the equivalent of my TableView cell for row at index path. So here's my view for annotation, and it's asking me, what is the view that corresponds to this model? So again, the syntax, remember, this can be any object type. In this case, I can't guarantee, or I don't know that it's called custom annotation, because this can apply to any type of class I implement. So it doesn't matter what class it is, but it must implement this MK annotation protocol. So the first thing I'm going to try to do is pull it from the cache. So I've just created this arbitrary identifier called marker. So if nothing was pulled from the cache, that's when I need to create one of these new views. So I'm initting with the annotation, nothing special there, defining each annotation to have its own button. So now at this point, I definitely have a pin. And that pin may have come from the cache. I may have just created it from memory. It doesn't really matter to me because I'm allowed to mutate it. So here I'm just setting the color, I'm saying I want the pins to drop, and I'm saying that I want them to be able to be interacted with. So this is what's actually going to define the views for the models that I've defined up here. So you see, I didn't say anything about pin colors or anything like that when I'm defining the models. It's not till down here that the views are defined. So exact same paradigm as the table view. So here are just some other delegate methods. Maybe I want something to happen when I tap one of them. And that's how I'm going to go about doing that. So let's run this. So right now you see both of the pins fell. And I can tap on them and get some of that added behavior. So this is now using my custom model and my custom view. And so we'll take a look at where these lines came from next. So as you saw, that circle and that line, those are called overlays. And overlays are, again, a feature that is also defined in the Google Maps JavaScript API, if you've ever used it. But basically what these allow you to do is define arbitrary lines and shapes. So again, we're still just dealing with coordinates here. We're basically going to plop down a series of coordinates onto the map and then connect them via a line, a circle, or any arbitrary polygon. So again, these are going to follow the same principle. The model is going to be separate from the view. So after I've created these two additional pins, now I'm going to create models for that line and that circle. So the first thing I want to do is create an array of these 2 points. So by putting these 2 structs into an array, I'm effectively defining a series of points to be connected. So I've just taken these structs I've already created and put them into a standard C array. So this is not, again, an NS array. This is just a standard C array. So again, this is kind of this intermixing of Objective-C and regular C. Turns out that the farther we go down into this low-level detail, as we'll see next week in core graphics and animation and more graphic-y stuff, we're going to start to use more and more C than Objective-C, perhaps for performance issues or simply design. So from this 2D array, I'm going to define a new line. So the line is just going to connect the points in this array in order. And so you'll see also that one of the arguments to this method here that is creating a new line from a set of points is the size of the array. And again, this is a feature, or not really a feature as much as a limitation of C. So in C, if I have an array, there's no way for me to just determine how long it is. Where in Objective-C, that's a nice luxury we have. We can just say count. We can't simply pass a message, an Objective-C message, like count, to a standard C array. So we need to actually, back in our CS, like we did in our CS50 days, define how long the array is, as well as what the contents of the array are. So there's our model. And again, we're going to add the model to our map view. And similarly, we're going to create a new model for that circle. Very simple. We're just going to define a center and a radius. Nothing special there. So now, if we scroll down, we have another analog to that view for annotation. So just like we call the method to ask this controller what each of the pins look like, we're now having a message that asks the controller what each of these overlays should look like. So when I said I want a circle, I didn't say anything about the color of the circle, the thickness of the line, or anything like that. I just said what the underlying data was. So now if I want to handle what is displayed, I'm going to come into this method here. And this is going to be called by the system. Because I've said this class is the delegate, the system knows where to pass this message to. So you'll see here that I'm introducing a new concept here. This overlay is kind of class. So you'll see here that the overlay that is passed in is just some generic ID. But I have here 2 types of overlays. I have a line and I have a circle. And I want those 2 overlays to look different, right? I want the line to be blue and the circle to be red. So right now, I don't know what it is that is passed into me. I just have an ID of some overlay. So I could do something like keep track of all the overlays I've added and see if this overlay matches something in my array, and then do something, pull the corresponding appearance data from that model data. But just for the sake of introducing a new concept, I'm using something here called reflection. So reflection is something that's really simple to do in Objective-C. And what this allows me to do right here is to determine the types of objects dynamically. So right now, this overlay is just an ID. But what I can do is I can ask Objective-C what its class is. So if Objective-C tells me the class is a line, then I can say I want this thing to be red. And if it tells me that it's a circle, I can say I want this thing to be blue, or vice versa, actually. So this returns not a string of the class, but actually an object representing a class, which is kind of hard to wrap your mind around. But basically, the way to get the corresponding class object or identifier for that class from the class itself, I'm going to pass in this class message. And you'll see here that this is an example of a static message. Right? When I say MK polyline, I'm now passing, that's the actual class. So I'm taking this message called class and passing it to the class. And from that, I'm going to get back an object that represents the MK polyline class. So a little bit hard to wrap your mind around, but basically this reads nicely. Is it this overlay? I want to know if it is the kind of class MK polyline. So this, in JavaScript, I would just get back a string that said something like number or object. But Objective-C, because it's more strongly typed, I need to get back some object. And that object has the type that this message is looking for. So now, at this point, I know that I've been asked for a line. So I'm going to set some properties that correspond to that line. So this method is asking back for some generic MK overlay view. So this is the parent class of something like a polyline, right? Because a line is just a more specific type of overlay, where overlays can have separate types. So I'm going to first create this more specific type as by allocating and initting. And you'll see here that because this is a view, no longer an MK polyline, but a polyline view, I need to associate with it some model. And this model was passed into us via this overlay parameter. So now I've associated the model that I was given with the view that I just created. So now from that view, I can define things like the width of the line and the color of the line. And then I want to return it. So same thing with the circle. So now if what I've been given is no longer a line but a circle, then I'm going to do something very similar. I'm going to take my model. I'm going to create a corresponding view, pass in the model that I was given, and then define whatever it is that I want to define. So in this case, I'm going to return that. So you notice here that I also have down here return nil. That's just to avoid the compiler yelling at me. Because if for some reason this is not true and this is not true, then I won't end up returning anything. But I've specified that this method has to return a pointer to something. So if I don't return nil down here, I won't be returning something when I promised the compiler that I would be returning something. So it makes sense there? OK, and finally, this is just my delegate method for what happens when I press that blue button. Not doing anything fancy there. But you'll see that I'm passed here some generic annotation view. But if I want to start using properties in the model that I've defined, I need to be sure to cast it to the model that I care about. So while this method knows that it can pass me something as generic as an MK annotation view, I know, because I wrote the map, that I'm actually dealing with something that's more specific, or a subclass of this, or which is a custom annotation. So by defining that protocol, that makes it safe for me to do something like this. And I've defined this annotation property that I can get from this generic view. So again, if I run this just to show you what's going on, there is my line, and there's the circle that I defined. Yeah?
Sorry, why can't the map views return? Why can't it be a void instead of and you have to return nil?
Oh, sure. So the reason this can't be a void is because this method is actually asking what should I display. So it needs to return an object that is going to be displayed. But if I had something like int add, and then I'm going to which is going to return some integer, and I don't return an integer, that's basically going to issue a compiler warning. So I said that I would return some pointer, and nil is just some generic pointer, so the compiler won't yell at me. I just need to return something.
Or you'd return that basically if I didn't get a circle or a line.
Right. So this would be returned if neither of these conditions were true. But in this case, they both will be true. OK. So related to maps is CoreLocation. And this is going to provide you a reliable way of getting the user's current location. So this is, in general, going to be a lot more accurate than anything you'll try to do in JavaScript, because this is really going to tap into the system's GPS. And you can very fine-grained adjust the accuracy of your readings. So again, we're going to have a new framework that we're dealing with, this time called CoreLocation.framework. We're going to add it in the same way, build phases, and then link with library. And we also need to be sure to import that header file in any place that we care about. So this CoreLocation now, so CL, the location manager is what's going to define some generic properties that will apply to every time you ask for a GPS reading. So some of these properties include the distance filter, or basically how far the device needs to move before the location is updated. So I mentioned here that this framework is event-based. So what I'm not going to do is ask the device, what is my location right now? Because that would start to get inefficient on battery, potentially, if I kept asking the user what their location was. Right? If the user is just sitting in a room, it would be a waste of time to continue asking what their location is. So instead, what's going to happen is I'm going to tell this location manager of which is really only one, that I want you to start updating the location, which will basically start polling the GPS. And only when the user's location changes by some amount that I define here in this desired accuracy, only when this changes is this going to fire a callback method to my class letting me know that the user has moved. So this is going to be much, much more efficient. I'm basically going to know where the user is and can continue to assume that's what the user is until the location manager tells me otherwise. So I don't need to continue asking for it. Obviously, I could implement this myself, maybe with some threading, but doing it this way just ensures that I'm doing this location stuff in the most efficient way possible. So on that note, it's also important that you don't abuse this thing, because it is a known way to drain the device's battery and have the users be mad at you. So if you don't actually care about the user's location and you've already started it, you can also say stop updating location to the location manager, which will conserve battery life if the user is moving around a lot. So like we said, we're defining callback messages here. As you might expect, defined in the delegate that's corresponding to this manager class. And the method that we really care about is this location manager did update to location, which will give you where the user previously was and where the user is right now. And so we know that that distance is going to be at least the distance that we defined here inside of this distance filter. And this desired accuracy is just going to be how accurate, to how many decimal points, basically, you want the user's location. So if we look at an example here, so again, really simple. I've been sure to include the framework. If I click the project, build phases, there's the library. I'm not using a map anymore. I just care about the location. So now I'm going to create a new location manager. I'm going to say the delegate for this manager is this class. So I want you to pass all of those callback messages to this object here. And so now I'm just going to define some settings. So these are constants that are declared for me inside of that CoreLocation.h file. We know they're constants because Apple has a convention of starting constants with a K for constant, I guess. And so this first constant says I want the most accurate data possible, and I want this to update every single time the user moves. So this no distance filter means every single time. And so now when I say start updating location, that's going to start this manager polling my device. So this is really the only callback that I care about. This is going to fire every time the user moves.
Can you highlight when you say this?
Yep, so right here, this is where I care about. This is the message that will be passed to me every time the user moves. Now I'm just going to set the text of two labels I have to the user's current latitude and longitude. So if you're using Xcode 4.3.2 and you run this, you'll see something like that. If you saw it flash really quickly, that was the pop-up asking me for permission to use my location. And then there's some bug in the simulator that appears to have just been introduced that hides that faster than you can click it. So that's the reason that I don't actually have latitude and longitude updating on my device here. So if you're going to use this in the current version of the simulator, you can't, apparently. So try running this on a device, and it should work OK. Hopefully, Apple will get this fixed. It's a known issue, as far as I know, that it's not working right. So don't be alarmed if all of a sudden you see nothing on the simulator. What you can try to do is to make you aware of the other things you can do with the simulator. If we fire this back up, quit the app. If we come over here to Settings, and I've turned my location services on, I can actually, let's see if that will work. If I open that, reopen the app. Yeah, so still a bug with the simulator. But what I can do is reset the warning by coming over here to General, Reset, and then Reset Location Warnings will ask the simulator to prompt you again with that pop-up. It's still running. Let me kill it first. Crash Xcode. And that will nicely crash Xcode. There we go. Run it again. Yeah. So where's the GPS coming from? Right now, Xcode is just going to hard code it to be Palo Alto, California. But if this were working, there's a way that I can basically feed it GPS coordinates, and simulate me changing location. So again, pop-ups just going to display too fast for me to do anything about it. This is not your fault. This is just kind of an issue with the simulator. So unfortunately, use your own device if trying to do this. So next, let's take a look at the notification center. And so this is not notifications in the sense of push notifications that you see when you get a text message or pull down the top of your home screen. But this is an internal system for sending messages, in this case not method calls, but actual messages to various controllers in your app. So this is the implementation of what's called the observer design pattern, in which case one object, called the observer, can observe or listen for changes in another object. So if you remember back to your CS50 days, in which case when you use Scratch, this is the same thing as those broadcast messages, whereby one object will broadcast a message, and any other objects that choose to listen for that message can respond to it. So it's implemented in much the same way. I'm first going to say, I want this class to listen for some message, and then as soon as another object broadcasts a message, any and all objects listening to that message, so there can be more than one, can respond to that callback all at once. So here I'm again using that flip side view controller just so that I have two classes. So this first class, the front side, the main view controller, is going to register to listen for notifications. So notification is just going to come in the form of some string. So this notification that I'm using, I've just arbitrarily called flip side notification. It doesn't have to be any type of special object. And so here's the syntax of doing that. So this default center message, this just gets the singleton instance of this NS notification center. It's just implemented as a singleton, so there's only one instance available to you. So it's just getting that one instance and saying that I want this object to be an observer for the message, flip side notification, and every time that this message is broadcasted by somebody, I want my selector called respond to fire. So just to recap, with this @selector keyword, that's basically allowing me to pass the following message as an argument to the method. So otherwise, I would just kind of trigger this message, whereby wrapping it in this @selector is going to allow me to pass the function itself as a parameter. So down here, I've defined what that message does. So this is just going to display an alert view. So whenever I get past notification, and here you'll see that the argument to this method is an NS notification, basically a container representing the notification that was fired, I'm going to display an alert to the user. So what I want to be inside of the array, or alert, sorry, is going to be what's passed to me inside of the notification. So every notification, this NS notification object, has a property called user info, which is a little strangely named. But all this is an NS dictionary, so it can contain as many key value pairs as you want, that is passed along with that message. So I'm saying that I want the message flip side notification to be broadcasted somewhere. And with that broadcast, I was passed along a dictionary that I'm hoping contains a key called data. And so I'm going to display whatever was passed to me inside of this notification inside of this alert. So that's receiving the notification. And my flip side is where I'm actually going to send the notification. So again, to send a notification, we're still working with the same object. It's still a singleton. And rather than adding an observer, we're now going to post a notification. So you'll see here that the name of that is going to match the notification that I was listening for in the other class. This object is just a way of saying what actually broadcasted the method. So from my other controller, I could determine who sent me this message. And finally, here's where we're defining that user info dictionary. So I'm just saying this single string is associated with the key data. So this message is going to be fired when I press this button here on the flip view. I've just created a standard IB action, connected them with Interface Builder. So when I run this, you'll see here that when I'm on this side and I click the button, I get the notification. And awesome was the string that I passed to the notification from the flip side. So you see here that even though the main view controller is not currently visible to the user, it can still do something like show an alert. And if instead of dealing with the flip side, I had a table view controller where I was several levels deep, and I had a bunch of observers listening for this message, they would all be triggered effectively at once. So what this allows you to do is rather than have to call like 5 delegate methods to make sure that you notify every class you care about that something happened, if you instead use the notification center, you can just say, I want to let everyone know. I don't know who's listening. I don't really care who's listening. But I want to let everyone know at once, and they can respond accordingly. So once you start needing to send these messages en masse, this is a lot nicer than having to do all of these delegate objects that can get annoying. Even though this is kind of similar to the delegation pattern, right? When I broadcast a notification, I'm effectively allowing other objects to handle what corresponds to that notification. So I'm not handling displaying that alert view myself. I'm delegating that task to another controller. In this case, the main view controller, which is going to display that alert view. Make sense? So now that we know all about the notification center, let's take a look at the media player. And so this is going to allow us to play movies of any format that is supported on your Apple device. Again, very similar structure here. Media player, H file, and framework file. Nothing different about how we're going to add things there. So the class we're concerned about to play movies is this MP for media player, or movie player maybe. So media player and movie player controller is going to manage all of your playback. One thing to note is you need to be sure to set a frame on this object. So when you just create a movie player controller initially, you haven't defined how tall or wide it is. So by default, that's going to be 0, which means that as soon as you add it to your project, it's not going to do anything because it has nothing to display. So you need to explicitly set the frame before the movie player can actually do anything. So the player, rather than using delegates, is going to take advantage of the notification center. So rather than asking you for a delegate to pass messages to, it's instead going to broadcast a series of messages when state changes occur in the player. So once it finishes loading, that's going to broadcast something. Once the playback state changes from play to pause, it's going to broadcast a notification, etc. So to respond to these notifications, rather than passing in a delegate or implementing some protocol, you're instead going to register to observe them via the notification center. So if we take a look at an example, so you'll see here that I haven't actually added any controllers to my nib file here. I'm actually going to do all of this adding in code. So one thing to note, which wasted a significant portion of my life, is you need to make sure that your movie player controller is defined as a property in your .h file. And this is specified in what I think is too small print in the documentation. But if you just create this variable locally, it's just not going to play. Apple just wants you to have this be a property of the class you're concerned about. So again, just as I did before, here's my forward class declaration. I'm telling the compiler, this thing exists. You don't need to know what it does. So because it exists, it means I can make it a property. And here I'm just defining 2 methods to respond to notifications that will be sent to me by the player. So if we come down here, you'll see here I've just defined a URL of some video. So this URL can be pulled from my applications bundle via that path for resource message we saw later. Or alternatively, I can supply just a URL to a video on the internet. And the type of this is not just a string, but an NS URL. And it's just a one-line message to convert from a string to a URL object that you can pass. So here is where I'm creating my player, and I'm telling it that I want you to play the contents of this URL, which in this case is just on the internet. It's going to handle downloading and buffering all for me. And so here's where I'm explicitly saying the size and shape of the movie player. So you'll see here that this cg-rect make is again jumping back to the lower level C language. So this is going to return to me a cg-rect, which is just a struct, and that's the type of this frame. So the arguments are, this is the top left corner. So this is the x 0, the y is 0, so this will be in the top left corner, and then the width and the height. So just 300, 300, numbers I picked arbitrarily to create a square video. So now we're going to register for notifications just like we did before. But this time, these notifications are not going to be strings, but they're basically constants that have been defined by Apple. So I'm not passing in a string. I'm just passing in this really long named constant to correspond to the notifications that will be sent by the movie player. So once I've created the player, I need to actually add it to my view, because we didn't do anything in Interface Builder yet, so there's nothing that's actually on the device's screen yet. So I want to add the view corresponding to the movie player. Remember, this is a controller. This is not a view. So if I want to actually add it to my device, to the device's screen, I don't add the controller. I add the controller's view. And I'm adding that, again, to the current view. So this self.view simply refers to this top-level container view. And that's been connected over here. I see that this view object, the view property of the file's owner, which is the view controller, has already been connected to this top-level view. So in this case, we're operating, in both cases, with not the controllers, but the views associated with the controllers. So once that's done, I'm just going to start to play the movie. So now to respond to both of these notifications, I'm just going to display an alert. So this first alert, I'm going to display once the playback finished. And the second alert, I'm going to display every time I change the state of playback. So if I run this, we'll see here that I immediately get a notification, because the state changed from not playing, because we didn't buffer enough of the video yet, to playing. So see the video is playing behind this message, because everything is asynchronous. So if I dismiss this view, you'll see the video starts playing. And I get for free all of these cool controls. I change the state there. I get another pop-up. I can go into full screen. And all of this is done for me via this movie player controller. So if you happen to be running these examples in class, I would not recommend running this one, because the video automatically plays, which is something I did last year in a very crowded lecture hall with my sound all the way up. So everyone got to hear David yelling, "This is something," when I ran this. So that's one way of playing movies. But you'll notice there that all of those steps required were kind of annoying. Like to create the controller and make the frame and play it and notify. It just seemed like a lot of extra steps. So being the fan of JavaScript and the internet that I am, we can actually just harness the power of the UI WebView, which does a lot more than advertised, perhaps. So if we open up this example, you'll see here that I'm just dealing with the FlipView utility app. And I've just added a UI WebView. Now this, unlike the media player and the CoreLocation stuff that we've looked at today, is already built into iOS and included for me. So I didn't need to add a framework or a header file. This is just there, much like an NS string. So haven't done anything special. I've just declared an outlet for that. The type is called the UI WebView. I've connected it and synthesized it, done everything special there. So if we look at our main view controller, here's a list of just some of the things that a UI WebView can display for you. So PDFs, movies, YouTube videos, not YouTubes. That'd be cool. So I've associated actions with each of these buttons to display just a URL. So you see here, here's a PDF, sorry. Here's the video we just saw, YouTube video, now Word documents, Excel documents that I randomly found on the internet. And being the good designer that I am, to avoid the repetition of code, I've just created this show URL method, which was not provided for me. And all this is going to do is it's going to take this URL and pass it to the flip side view controller. So we're going to display the other side of the app. And then the video or content is going to display. So if I run this, so let's take a look at the video first. So now I click this, and I'm going to immediately jump into full screen mode. So this is perhaps one of the disadvantages of using a WebView. I can no longer say that I just want this to cover some subset of the screen. I can't say I want this to be 300 by 300 anymore. I basically have to deal with this full screen view. So I can zoom in and out. All the controls are still there. But once I exit full screen, you'll see that I don't really have much control over this. So I click Done. But I can also view PDF. Again, I didn't do anything special here. Didn't have to download a PDF library or anything like that. YouTube, it's going to work much the same way. I'll automatically be taken to YouTube's mobile site. Don't have to deal with trying to convert those videos or anything. Word documents will display nicely. Penguins are funny birds. And finally, what I think is really cool is the Excel spreadsheet. It's pretty crazy that it actually even handles like separate worksheets on the spreadsheet. and nicely displays spreadsheet content. So again, this might be something that initially you'd be tempted to implement yourself and try to Google like iOS Excel parser library and then get this totally crazy thing that you try to use. But there's a really good chance that the content you're trying to display is already implemented by the UI WebView, which is really, really handy. So before we end, I just wanted to show everyone this cool link that I found fairly recently. This is a project called the UIKit Artwork Extractor. So as you start working on your project 2 and your project 3, you might notice that a lot of Apple's system icons are kind of locked down or hard to find. Whereby jQuery Mobile had that nice icon pack built in, and you're certainly free to use those icons again. They're not really native. They don't really look native and fit in with the iOS theme. So what this app allows you to do is you basically download it as an Xcode project. You'll run it, and it will extract all of the artwork on the device. So things like the Wi-Fi icons, the battery icons, the various check marks, and other controls that you'll probably want to use, and save them as image files on your computer. So I just did this before class. So I ran this just on a Retina display, and it even organizes everything by framework. So if I open Media Framework, for example, you can see there's a Bluetooth button, some volume, and other things that you might be tempted to Google around for online. And according to very credible sources on the internet, this doesn't result in rejection from the App Store. People have said that Apple is totally OK with you using these icons. So this might save you a lot of time Googling around as you try to create a cool-looking project 2 and 3. So any questions on anything we went over today? All right, if not, then don't forget about code reviews and office hours this week and next. And good luck finishing up Evil Hangman.